Hello again. Let's look at this example. X squared plus y squared equals 36. Now guys, I want to find dy by dx. So what I'm going to do is I'm going to stick d by dx's on both sides, here and here. Now the derivative of a constant is just 0. Now d by dx of x squared, that's just 2x. D by dx of y squared, now watch out. That times sign is correct, but that times sign is correct with sloppy. D by dx of y squared, that's 2y, dy by dx, and I wanted to get rid of that sloppy times sign. Nothing wrong with it, or there wasn't anything wrong with it, but it was sloppy. So d by dx of y squared, that's 2y, dy by dx. Because remember, you got to stick this dy by dx here because you're derivating with respect to x, which is foreign to y. The variable types don't match. You have a y and an x, okay? Now that implies that, and again, this time, so it's sloppy. That implies that x plus y, dy by dx equals 0. Okay, I divide everything by 2 by algebra. 0 divided by 2 is just 0, and the 2's just disappear here. I divide this by 2, divide this by 2, divide this by 2. Alrighty. All right. Now, and then this time sign is sloppy, so it's just an eyesore. So I have y dy by dx equals negative x. And so now I just divide both sides by y, and I get dy by dx is negative x over y. Now we are assuming, there is something important here. We're assuming that y is not 0. And to be honest, I'd rather x not be 0 either. Y cannot be. I'd rather x not be 0. And we don't have to, I guess there is that one situation where we could have x equals 0 and y equals either 6 or negative 6. But as long as x is not 0, we just have, we have this guy, we don't want y to be 0, my bad. So we don't want y to be 0. So if y is 0, x would be 6 or negative 6. So we don't want y to be 0. Now, if y was 0, we would not be differentiable because we would have a vertical tangent. What that means is you would be on the circle, you would be, your tangent line would be totally vertical. It'd be infinitely steep. So dy by dx would be negative x over y, and it would be, it'd be undefined when y is 0. But anyway, in particular, like if we were at the point radical 11 negative 5, and I'll give you that point, I wouldn't make you make this up. And you can check that if I square radical 11, I get 11. If I square negative 5, I get 25. And 11 plus 25 is 36. X squared plus y squared is 36. So in particular, at this point right here, I would get negative x over y. That would be the negative of, you know what, I have this backwards, don't I? My bad, guys. Oops. The radical 11 would go up here, and I'll save this in the editing, by the way, as I always do. The negative 5 would go down here, and I'm sorry about that. This negative here would kill this negative here. And so I would actually just get radical 11 over 5. My bad. And this would be, I was totally wrong. So that would just be radical 11 over 5. And so there's that. Sorry, guys, I messed this up a minute ago, but I corrected it now, and I'll save this for the editing. So there's that. And okay, now, so what have we have found that the slope is positive radical 11 over 5. Okay, just positive all the way, radical 11 over 5. That's our slope. Remember, derivative is slope. Dy by dx is our slope. That's the slope of the tangent line at that particular point, namely this point right here. Okay, so what's the equation of the tangent line at this point right here? Let's say that we're asked for that. Well, we do point slope. Remember from algebra, we do point slope. Y minus y naught equals m. Well, this is the wrong m because I'm using the incorrect m I had it from a minute ago. So my slope is going to be radical 11 over 5, remember. So y minus y naught equals m, my slope, times x minus x naught. But remember, we're doing x minus a negative 5. That turns into x plus 5, okay? Because we're doing x minus an already negative 5, so that's x plus 5. Because x minus a negative 5 is x plus 5. Our slope is radical 11 over 5. My y-coordinate is just plain radical 11, so y minus y naught is just y minus radical 11, because y naught is just directly radical 11. The minus sign, survives. There's nothing for it to bump into other than radical 11. But this minus sign, x minus, that negative bumped into another negative with the, namely negative 5, and we got the plus 5. So now this is the point slope form of the equation. And I'm not going to make you go into slope intercept. We could do slope intercept without too much trouble. Actually, it would be quite easy. To get slope intercept, you would just, you would have y equals, you distribute the radical 11 over 5 through these parentheses. You would have radical 11 over 5 times x. And the x would really be understood to be up here in the numerator, not inside the radical, just up there in the numerator, okay? And then, but we'll leave it out to the side. That's actually the more standard way to write it. And then plus, now radical 11 over 5 times 5 is just plain radical 11. And then, now this minus radical 11, now it wasn't in the distributive. It just moves across and becomes plus radical 11. But hey, that'll give me 2 radical 11. Radical 11 plus radical 11 is 2 radical 11. So, and now this is called the slope intercept, if you recall from algebra. And this is called, the guy I had from a minute ago is called the point slope. Okay. So, just, you can use, it depends on what your professor asks for. So, if he or she asks for point slope, you'll have to give him or her this equation. And if he or she asks for the slope intercept, you'll have to give him or her this equation. So, slope intercept versus point slope, okay? There's that. And let's see. I don't want to drag the video on much longer. This one is quite long. Guys, let me save this one for the next video, because this one is going to involve some detail. So I'll stop the video here, and let's resist the temptation to do this guy until the next video. Thank you. I'll see you on the next video, and we'll do this guy on the next video. Thank you. Bye-bye.